there, Ms. Lams here. In this video, we are going to talk about correlation coefficient, also known as R-values. Now, most of the content in this PowerPoint comes from toptipbio.com. So if at any point in this video you got confused, please feel free to pause the video or go to this link. I will put this link in the video description below. So this table comes from IB, and they were saying that like what kind of statistic tests they expect candidate to do based on their experiment design. So for instance, okay, when we do R-value, we expect candidate that to do the IV and the DV, the independent and dependent variables, to be quantitative. That means that both IV and DV are numerical. So this slide comes from November 2020 from the examiner report. They stated that after you have done the correlation coefficient, R-values, they should also have a significant test. Okay, and the significant test is of the correlation depends on the sample size. That means that when you do your R-values and when you do your significant test for your R-values, you should take into account of all the trials. You will understand it a little bit more as we go along. So first thing first, what is R-values? So R-value is a statistical way of showing a linear correlation between your IV and your DV. Generally speaking, it's ranging between -1 to +1. And basically, as you can see here, the closer the R-value to +1, the stronger the positive correlations between your IV and DV. And the closer it is to -1, that means the stronger the negative correlation. And if it's very close to 0, that means there's weak or no correlations. Now, how do we calculate the R-values? Is that there are two ways to calculate it. One is that in Excel you can type =, correl, and then you highlight all the data set 1, so for example your IV, and then comma, and then highlight your second data set. So could be your DV, okay? Or alternatively, you can just type =, Pearson and do the same thing again. So just now, as the examiner report mentioned, we need to do a significant test. So and the significant test is a statistic test, and generally speaking, for statistic tests, we prefer as much number of trials as possible. So we will use all the trials data. Otherwise, the data set is too small for the degree of freedom. So this page is the key formulas. Don't worry, don't panic. You can feel free to pause the video or go to the website's link for it. It's just a summary, and it also is a way, a flow chart of what you should do when you do your R-values, when you do your significant tests. So for example, first one, very easy to calculate the R-value, you just type in this formula. And then same thing is after you have done that, okay, you should know that whether there's a positive trend or there's a negative trend. So for example, if it's a positive trend, then you will use this formula. And then step 3, then you need to calculate the t-stats, okay, so significant values, okay, and then after that you need to calculate the p-values, and then finally after you've calculated the p-values, you need to conclude it. So for example, if your p-value is more than 0.05, that means that we are at least 95% confident that the result is significant and it doesn't happen due to chance. Okay, so and then the same idea for the negative trend, so just that you will use a slightly different formulas. And in this page, you will notice that there are a few things. So for example, what does R stand for? R is the R value that you calculated previously. And then N is the number of trials. Okay, so number of trials. And let's see, anything else? I think that's about it. Okay, and then X is t-stats. Okay, so that is what you calculated previously. Degree of freedom. So don't worry too much if you got a bit confused on this page. We will show you a few screenshots of what to expect step by step in the next following slide. Okay, as usual, I will, if you want to try this out, best way to perfect a skills is to try it out. So I will put the link for raw data in the video description below. Alright, so for example, if you have no time for that, then I can show you what will you expect. So if you click on the link for the raw data, you will see two sets of data. One is the positive trend, okay, another one is a negative trend. So in the positive trend, you can see that the IV of the concentration of, let's say, green tea or whatever, and then we look at the bacterial colonies, okay, and you can see that as this increase, okay, so that's a positive trend. And then there's another data that's negative trend, so and so on, okay, so the concentration of something, and then the bacterial colonies number is actually decreasing. Okay, so first step, okay, we use the Correll or Pearson function to calculate the R values. So just simply on an empty space, just type equal sign Correll, and then you highlight the first data set, and then comma, and highlight the same data set, okay? Do the same for Pearson, they do both result the same thing, okay? Same thing as well. As you can see here, this is negative 0.92, this is also 0.92, okay? Negative 0.92. Right. Then the next part, just type number of trials. It will be easier to refer to it as you do the other few equations. Okay. And then so this is a positive trend. So we use this formula, and then we replace the R values. Okay, the R with the R values. Okay, and N is the number of trials. So you can see that when we do the T statistics. Okay, so here I just, instead of R, I will type E10, which is the R values, okay? And then E13 is the number of trials, okay? So, and then that's your T statistics, okay? And then if this is the negative trend, okay, you use a slightly different formula, okay? And then just sub in the R value and the degree of freedom. And then finally, we use the we need to calculate the p-value for the t statistics, so the significance test. So use this formula. X is actually the t statistic that you previously calculated, okay? And then degree of freedom, okay, so degree of freedom. That's why it will be easier if you type degree of freedom separately rather than type n-2, okay? So, and then tau, we prefer 2 taus, okay, it's t-test, so tau is 2. And then this is what we get for your positive trend and your negative trend. So the p-value for the positive trend is about 4.83 to the power of negative 11. So that's much smaller than 0.05. So that is a significance, and the result did not happen by chance. So we can be quite sure that at least 95% confident that what we state in this R value is true. And then do the same for the negative trend. Okay, so turns out the p-value is also smaller than 0.05. So again, this negative trend is significant, okay, and the result did not happen by chance. So that's about it for the R values and also the significance test for the R values. Next, I just want to very quickly refer back to the R-squared values, which is a completely different thing, but a lot of candidates often muddle up. So here, this is the coefficient of determinations. So there are two things about R values and R-squared values, okay? So R value is usually using a small letter r, okay, lowercase r, whereas the R-squared value is using uppercase, so capital letter, R-squared values. So apart from the format, okay, displays format, another thing is that the differences. So the R value is talking about the linear correlations between your IV and your DV. Whereas the R-squared values, okay, is talk about how most of the data fits the trend line, as you can see in the next slide. So it's an indicator of showing the goodness of fit of the trend line. So what that means is that, for example, this is some data set, and then you can see that here, oh, it did, oh yes, it did explain. Okay, so this is a positive 0.8. Okay, so actually most of the dot fits quite nicely on the trend line. Okay, so R-squared value negative never get a negative value, so it's ranging between 0 and 1. So they will talk about how well fit it is. So as you can see here, this is actually a 0.8, so that's quite a strong R-squared values. Okay, so most of the data fits onto the trend line. Okay, so that's the idea. Most the closer the 1 to 1, okay, the better the trend line represent the data. So that's about it. I hope this video helps you to understand what is R value, how do we do a significance test for R value, and what is the difference between R value and R-squared values. So that's it. Bye for now.